Good afternoon, everybody, and welcome to Ellensburg, Washington, USA, home of Central Washington University. Thank you for joining us today. So glad that you continue to watch these programs. We're deep into the series now, and yet you don't go away. You keep coming back, and so I'm grateful to you for that. The local time is approaching 1:47 p.m. on a Wednesday afternoon, and we will begin our program at the top of the hour. That's a little more than 12 minutes from now. 2 p.m. Pacific time. It's in the high 30s Fahrenheit. Rain off and on. Most of the snow here is gone in Ellensburg. I'm happy about that. Back on my bicycle. It's cold, it's wet, but I head back and forth a couple times every day between home and school, and it's nice to be back on the bicycle. Are we 5x5? Looks like we are. Thank you for that. Let's say hi to a few of you and have a few quick announcements, and then we will, you know what, I'm going to email Randy right away. For some reason, I just feel like I want to do that before I forget. Randy Enkin. Another Canadian today, everybody. Okay, the email has been sent to Randy, so let's go ahead and say hi to everybody. I'm live right now. I might scroll back if there's too many people to read here. Hello from Claudia in Atascadero, California. Oh boy, come on now. Come on, baby. Come on, baby. Uh-oh, way too fast. Let me scroll back. Pinehurst, North Carolina. Lake Chelan, Glasgow, Scotland. Gordon says, evening all. And snow is coming down, says George. He's somewhere. Harold is in Lichtenberg/Austria, 5x5. Thank you, Harold. Powell River, British Columbia. Greetings from the West Coast. Finally caught up to a live presentation. Thank you, Cuddy22. I saw a number of you a while ago saying you've been kind of furiously watching these, and now you're caught up and you're live with us. So I'm especially grateful to those of you who are, you've caught us live. You're back up to speed. That's great. That's really fun. Chula Vista, California, Hayward, California, Church Mountain Slide, Vancouver, Washington, San Juanico, Scorpion Bay, Baja, California. Oh, that's Saber. Hey, Saber, you're still down there. Very good. Stevens in Selwood, Oregon. Eric's in Marion, Virginia. Neil's in Portland, Oregon. Robert is in Marionette, Wisconsin. Thur says howdy from Wibaux, Montana, Wibaux. Bill says Pinehurst, North Carolina, checking in. El Cerrito says chaya chaya. Let me go down to live. Williams in Natchez, Washington. Rebecca says hi from northern BC. That's fun. Hi, Rebecca, way up there north there. Oh yeah, cool. Oh God. Jesus Mendoza is in Stockton, California. Hello, Jesus. Bob and Kathy in Woodinville, Washington, and Gary is in Saraland, Alberta. Perhaps, maybe Alabama. Grew up in Soap Lake, Washington. Uper, that's John in Menominee, Michigan. Phil's in Washington. John's in Media, Pennsylvania. Rogue River, Oregon. Hey, there's Randy. I see Randy in the green room. That's good, Randy. That's nice to see. Thank you. Mr. Steve is in Eugene, Oregon. Rock Tapper Robin is in Yorkshire, UK. Crystal River, Florida, that's checking in. Jason, that's very good. Rick's in Costa Rica. Hey, Rick. Colorado Springs, Colorado. Veneta, Oregon. I'm down to live. Things are slowing down finally. Tez is in Tasmania. You know where I am. Oh, no. Okay. Elaine's talking to, okay. Very good. A couple quick announcements. First one is if you're a fan of the channel, and you watch everything, including the pre-recorded things out in the field, you know Andrew Sadowski, who has an office just down the hall from me, and occasionally I go out and visit with him. He works for the Washington Geological Survey. Well, Andrew works very hard for the Washington Geological Survey. He's a field mapper, so he's busy all summer. So he just got back from a winter vacation with his lovely wife. They just got married, and Andrew was walking around an hour ago giving presents to everybody. So Andrew and his wife were down in the Caribbean and just gave me this. I was chatting with Hannah Shamloo, and he gave each of us one of these. And so if you need motivation to stick around till the end, we'll open this up and eat this together, I guess. All right? So I think it's a rum cake. Yeah, Caribbean rum cake from Andrew Sadowski. I told Andrew I'd share it with you all. So thank you, Andrew, and thank you to those that are saying all sorts of stuff about rum cakes. What? I'm thanking you for making comments? Weird. Okay. Slightly flustered because I've got a bunch of things I want to say before we start. Again, if you're a veteran of these live streams, you know that during the school year, and yeah, there's students all over the place, and they're all in lab and talking to me, and I'm like, I got to go, and they're like, what? So anyways, there's lots going on here at CWU Geology. Well, they're walking by right now and waving. You know that occasionally on Fridays, we do a live stream of a guest geologist or a guest somebody. And if you're interested, in addition to keeping up with this series, keeping up with the Talk Friday series, I've already announced this once, but I want to announce it again right now. This coming Friday, just 2 days from now, less than 24 hours from now, there will be a live stream from this room by Darcy Snowden, who is a physics professor here in this building. There's her talk. She has a sweet NASA grant, and she's got all sorts of programs going on. I think she has both a geology and a physics background, an astronomy background. So I don't know what she has up her sleeve, but that's her talk title. And if you want to see that show live, it'd be fun to have some of you with us live. And I've mentioned this already, that I'm just going to start live streaming about 10 minutes to noon this Friday. You'll just have to look for some sort of notification. There won't be anything to join ahead of time. So that's Darcy's talk on Friday. And then you know our schedule here with the Baja BC series is every Wednesday afternoon, like right now, and every Saturday morning. And that will be the case on Saturday morning at 9 a.m. Pacific, but I'll save that announcement until we start for real in a handful of minutes. Let's say hi to a few more. Do I have anything to announce? Okay, Randy, good. Randy's got his slide bank ready to go as well. Terrific. I think we're good, Randy, there. And I'm thinking, I don't know, 15, 20 minutes maybe, chalkboard. I had fun filling the boards with all sorts of stuff. So, and then we'll come to Randy. Marysville, Washington. Sydney, Australia. Hello, Jeff. Phil's an index Pluton. Ivana's with us from the start, not joining us late. That's a switch for you, Ivana. Nice. A burnt rum cake might be a carbonatite complex. Oh, Ivana, have you ever just done like a casual fun comment? You're so dense with your information. You're an impressive guy or gal. I'm not even sure, but you're impressive for sure. Just teasing you. Northwoods 3Ds in Unity, Wisconsin. Go Badgers. Grandpa Carl in the Granger Clay Pit. Susan says hi from Oroville, Washington. Brent in Salt Lake City, Utah. Yeah, we got more Canadians here. I mean, we're deep into the Canadian roster now. Come on now. Everybody's so nice up there. Diane's in Calgary. Thought I saw another Canadian. Whatever. Leslie's in near Boston. Trevor, Nanaimo, British Columbia. Via Kona, Hawaii. Jealous. John's in St. Catharines, Ontario. Okay, now we got the Canadian roll call here. That's fun. PJ says hi from Coldstream, BC. Now Lindsay's putting all sorts of Canadian flags and hearts and everything. All right. Very good. Oh, I'll never get over this. I mean, I've been doing this for 2+ years, you know. Started in my house, and now here I'll never get over this. This is just so crazy. And somehow the foreign countries just occasionally just like, what? Most of the time I'm kind of numb to it, but occasionally, like today, Maurice from Vancouver and Vincent from Montreal. And now people are sad I'm talking only to Canadians and not them. Okay. Yeah. Totally a blast. Bernadette says we got more than 500 here. Yeah, okay. You missed the backyard in Bijou. I understand. That was a weird time. Weirdly nostalgic for a really weird time, but yeah, it was intense and quite intimate, and for reasons I've already shared, we're not going back to my backyard or my house. Them's our orders from the boss. I want my privacy. That's a quote. I want my privacy. Like, all right. I got you. Okay. We're approaching the 2-minute warning where I have to get my head right. Randy's in the green room. His slides are in the green room. What am I forgetting to do? The answer is nothing. Nothing. I haven't forgotten to do anything. Except to say, thank you for joining us. We will begin the program in 2 minutes. Hot mic. Okay, you're feeling too good. Why? Just like last show, you were in a good mood. You were feeling great. It's partly because of the technology. Now, you just jinxed it again, but you're not worried about the crash business. So that's a positive. That's a positive. You're just not thinking about that tech. So that's good. You're also confident in your guest today. He's got slides. He's going to fill in a bunch of gaps for us. Good. So let him do that. What do you have? You've got about 3 boards full of stuff. What are you going to do with it, boy? You're going to lob some stuff out, as usual, but you have most of it written out. So just let the chalkboards do the work for you. Translate what's on the boards, but you don't have to do a lot of heavy lifting here. You're just explaining what you've written out in all your fancy colors. Isn't that cute? You don't have to scream. And you're also talking directly to Randy as you work with the chalkboards. And like, do I have that right? Do I have that right? Am I putting a narrative together that's incorrect? Yeah, that'll work that way. And then Randy takes it from there. Use the viewers more. Have an expanded Q&A session. I think this might be the guest for you to do that. So don't be rushing to wrap things up. Allow things to breathe with the Q&A. Okay. At this point, the series is running itself. You're just part of it. You're not even leading it anymore. You're just part of it. Just letting it roll. Let the whole thing breathe and just lean into it. Let it happen. Don't force the issue. You can do it. You can do it. Welcome to Ellensburg, Washington, everybody. Central Washington University. It is a Wednesday afternoon here in midwinter, and I'm so glad that you're with us today. Our guest today is from Sydney, British Columbia, Randy Enkin, and I want to spend some time setting up Randy with the chalkboards and a few other things, and then we'll get to Randy as soon as we can. I think we will learn a lot today because this is kind of a cleanup show. This is the 4th of 4 paleomagnetic shows. Bernie Hausen, the first show, Bernie Hausen, the second show, Jane Wynn, the most recent show, and now running the anchor leg, Randy Enkin. And Randy's been watching these, and I think he wants to kind of fill in some gaps that we may not have with our paleomagnetic knowledge. Looking forward to that. But I'm also going to lob out some questions where I think I see what Randy is saying in certain papers, but I'm not sure that I see it. And so he's going to clear up some things for us, I think. I did some enjoyable reading of 3 major papers that are in this special paper 46, Paleogeography of the North American Cordillera, Evidence for and Against Large-Scale Displacement. This came out in 2006, and 3 of the major papers I have for you from Randy are directly from this volume. I have electronic PDFs for you, but I was sitting like this, reading this thing for the last few days, thoroughly enjoyed it, and we'll see if I have some angles that may work for Randy and for you all. Okay, well, this isn't really much of an outline here on the board, but let's just go ahead and jump into this. Actually, no, let me do one quick thing. So this is quick. You know, this is our routine. I will see you next for show R on Saturday morning at 9 a.m. And you're like, well, who's that going to be? If we're done with the Paleomag, who's that going to be? Well, I don't know if we're going to be done with the Paleomag. We're going to keep referring to the paleomagnetic data sets, but this is the last of the major kind of thrusts into the paleomagnetic world. Our guests on Saturday morning, one will be from France and one will be from British Columbia, Karin Siglock and Mitch Mahoney. Looking forward to that very much. We had Karin last winter, but I've never met Mitch, and have not met Stephen Johnston either, who's the next show after that, and then a couple of Bob Hildebrand shows as well. So things will get wild for sure. Very much looking forward to that. But we're not there yet. We're still talking about the details of paleomagnetism with our guest, Randy Enkin. So here's a place to start. It kind of dawned on me this morning as I was trying to put these names and places together. There's kind of an interesting symmetry. We started talking about Paleomag with Bernie Housen, and Bernie Housen took over for Merle Beck in Bellingham, Washington at Western Washington University. And for most of the 70s, 80s, and 90s, Merle Beck had a right-hand man, as he called him, Russ Burmester. And I approached Russ about being part of this, and he said, I'd be happy to help you by email, but I'm not interested in being on camera. That's fine. Okay. So we didn't get Merle, we didn't get Russ on camera with this series, but we do have their papers, and thankfully we have that. And again, we had Bernie a couple of shows ago, twice. Going up to the Geological Survey of Canada, headquarters in Sydney, British Columbia, where we're going again today. I think I have this right. Ted Irving, who we heard from with Jane Wynn. We learned about Ted Irving with Jane Wynn in the last show. They were a dynamic duo. And then, as I understand it, Ted Irving retired and Randy Enkin replaced him. The reason I mention that is Bernie has been continuing to kind of refine and come up with calculations that just double check, as I understand it, for lack of a better term, from those original works by Beck and Burmester. I think Randy's had the same approach. He's revisited the Mount Tatlow. He's revisited the Carmacks, some of these other studies that Ted and Jane were doing, and was using some methods to refine, improve, clarify, use different reference poles. Now I don't even know what I'm talking about. But there's this interesting parallel between Sydney, British Columbia, and Bellingham, Washington, which are not that far away from each other. Okay, that's not an outline, but that's the idea. Where are we headed today? Well, you saw the title. Churn Creek keeps coming up, starting with the Paul Link, Brian Mahoney show. Churn Creek, Churn Creek, Churn Creek is a problem. Well, I think it's still going to be a problem after today's show, but we're going to hear more about Churn Creek from Randy in just a few minutes. And also, really for the first time, we're going up to the Yukon and looking carefully at the Carmacks volcanics, which I think are an important place for us. Randy has some work on it, and that's where we're headed as well. So what else do I have on the chalkboards? Well, getting rid of this, not using it again. Some of this is going to look familiar, and some of it's new. And that's the whole thing that I try to do, you know, with these opening few minutes. I try to grab narratives from past shows, bring them into this show, set up the guest, and then we continue. So what looks familiar? Well, even though we're in a place called Churn Creek now, there's MT, there's our friend, Mount Tatlow, with magnetization 90 million years ago, and Bernie's numbers from the brand new paper 2023, 2,800 kilometers of northward translation. And Churn Creek, as we learned in the last episode, sits directly on top of the insular superterrain, the whale, the Baja BC block, which we haven't really used that phrase in quite some time. I'm not sure how valuable it is, to be honest, as I continue to read. But that looks familiar from last show, doesn't it? Okay. Well, when we go to Churn Creek itself, you can see why Bernie Hausen has had two different reports of Churn Creek. And he used, these are Bernie Hausen's letters from the brand new paper, CH and CC. Again, I keep seeing you folks in the comments saying that's Cache Creek. It's not. I've triple checked it, okay? So you can see that there's detail at Churn Creek where we have Churn Creek that has 3,000 kilometers of northward offset because of shallow orientations. You remember my cartoonish message here that if you have shallower than expected inclinations of your ferromagnetic grains in lavas or sedimentary layers or plutons, that indicates far-traveled, low-latitude original material. And if you have steeper inclinations of those grains, you're not as far south originally. Well, I'm trying to show you that there's, towards the top here, 87 million year old magnetized material, lavas and sediments at Churn Creek that have shallow inclinations and therefore 3,000 kilometers of northward offset. That's Bernie's number. We'll see if Randy has the same thing. I should know that. I don't right off the top of my head. But if you remember the Mahoney and Link show, Mahoney and Link say, look, this is a depositional contact where you have far-traveled stuff sitting directly on top of more stuff at Churn Creek that has steeper inclinations, much older rock, 102 million year old material, lavas, sediments. And if you have steeper inclinations, that stuff hasn't traveled as far. So my code here is yellow is insular, blue is intermontane. So why is Churn Creek a problem? We got both insular and intermontane signatures in the same place. Basil, a few shows ago, says, I got to go up to Churn Creek. I got to look at that boundary and see if it's not a fault boundary instead of a depositional contact. But he's not the first to wonder about that. This is weird. If the paleomag is accurate, why do you have that relationship? It's a question mark. And so therefore, we leave the insular story. We take the blue, we go over to Spences Bridge lavas nearby, still in south central British Columbia, and we have 104 million year old lavas that have 1,000 kilometers of offset to the north. Again, Bernie Hausen's numbers from 2023 on top of the Intermontane. The wild card today is if we leave south central British Columbia and we magically take a carpet ride up to Yukon, we get to the Carmacks group, 70 million year old flood basalts that show 1,400 kilometers of northward motion since 70 million years. What do we do with that? We're going to try to get a start on that today with Randy. Okay, I'm going to keep most of that on frame if possible. Not really though, I guess. I'm going to just do this. So this is the one that I think I'm most proud of. I had this brainstorm this morning with Bijou. We'll see if you like it. And if Randy likes it as well, I'll keep it. We'll just keep using it. I just want to try to explain what I have here on the board. Canada, USA, Mexico. Here's the 49th parallel. I just grabbed a number that's close. 32 degrees north is the boundary between Mexico and USA. I'm sure you'll quibble, but okay, play with me. Yellow, insular. Remember? Mount Tatlow, Mount Stewart Batholith, Churn Creek, the far-traveled stuff, Churn Creek, the stuff that didn't travel as far. So yellow is insular, blue is intermontane. I hope it's self-explanatory what I'm trying to plot out here, but just in case it's not. And again, these pink numbers are Bernie, 2023. Mount Tatlow, 90 million years ago, was potentially in Southern California. And between 90 million years ago and today, Mount Tatlow goes 2,800 kilometers. That's the last show with Jane. Mount Stewart Batholith, that's going back to Merle and Bernie. Mount Stewart Batholith, 90 million years ago, is in Baja at latitude of 31.3 degrees north. It moves an equal amount, similarly, in the same ballpark of northern translation, 47.6 degrees north latitude for Mount Stewart Batholith. Slow down, boy. Churn Creek. You just saw the Churn Creek stratigraphy. That stuff on top, 87 million years old down in Southern California, shallow inclinations. It gets the grand prize. According to Bernie's numbers, 3,000 kilometers of northward transport, which gets it up to 51.4 degrees north, which is the present latitude of these sites. Mount Tatlow, Churn Creek, Spences Bridges are all about at the same latitude, as far as I know. Well, now things get wild. For me, I'm sure I don't have it right, and thankfully we have Randy today. We go blue, that's fine, we're intermontane. Bernie's reporting that the 102 million year old Churn Creek stuff, the stuff with the steeper inclinations, was at a latitude of 55 degrees north. And here it is today, south. And yet he's reporting an 800 kilometer movement or translation of the Churn Creek stuff that has steeper inclinations. Well, I don't know what to do with that except to assume that the general message, and I think Randy's a proponent of this, we'll see in a second, is that you take that old, that Churn Creek that is part of Intermontane and you send it now south to, I don't know, Southern Oregon, and then you send it back north. This is the first time we're thinking carefully about this yo-yo idea. Same for Spences Bridge. Originally up here, 104 million years ago, at latitude of 50.8 degrees north. Using the Paleomag, we send it down to Northern California, then we bring it back north to its present location. So it crosses the border twice. And then this is all whack, because I can't even get it on the chalkboard properly. The Carmacks, 70 million years ago, is at the latitude of today's southern tip of Alaska, 54.9. That's where it starts 70 million years ago. Then it travels, Bernie's number, 1,400 kilometers north to north of present-day Anchorage at a latitude of 62.1. These are all buried in the Bernie Housen 2022 paper. That's the joint paper with Basil. And you're like, why do you keep using Bernie's paper if you got Randy today? Well, I can use an example of, what can I do? Here's just, I ran out of chalkboards. Here's my just sketch to myself last night. And I've got the Carmacks, which is essentially a 70 million year old flood basalt story. Flood basalt's on top of the Yukon Tanana. And yeah, we are so far east now and so far north, talking about the Carmacks up in Yukon, that it's between the Tintina Fault and the Denali Fault. Well, can you read my chicken scratch here? Bernie, 2023, has 1,400 kilometers of offset. Steve Johnston and Jane Wynn, 1996, has 500 kilometers more of northward motion. And Randy Enkin and Steve Johnston in 2006 have even more. They've got almost 2,000 kilometers north. So among other things, I want to learn from Randy why these numbers are so variable and why sometimes Randy's numbers are more conservative than others, and why in this case Randy's numbers are less conservative or more far-traveled than even Bernie. Finally, I can't hold it with this. The known amount of offset that we have on the Tintina Fault is 400 kilometers. And that's less than 1/4 of the offset that we need to send the Carmacks north. These are brand new thoughts for us. And by us, I mean me. And so in Randy's paper from 15 years ago, he says, we got to look east from the Tintina to find a Baja BC fault. He didn't say it that way, but so for today, I've been flirting with this. For today, we're going east in a substantial way. And I think we're going to continue to be looking far east than where we were in the first part of the series. I got one more chalkboard and we're going to Randy. Still lobbing out ideas. I'm not even going to the laptop, Randy. We're just going to go directly to you. I got some, after I'm done with Randy, we'll look at the papers that I have waiting for you, but I want to get to Randy. I could be barking up the wrong tree now, but just throwing out a couple other things, which I've gotten from Randy's 3 major papers in the 2006 volume. Looking at a map, cartoonishly, here's what I think Ted Irving and Jane Wynn were proposing back in the mid-1990s. We have insular superterrain, the Whale. We have Intermontane superterrain. And some sort of Baja BC fault in between the two. Remember the whole first half of the alphabet before Christmas, I kept looking for that Baja BC fault between the two. I'm not giving up on that, but if you like this approach and you like the insular superterrain traveling 3 times as far north as the Intermontane, then we need a major Baja BC fault in between the two of those. And 1,000 of the 2,000 mystery displacements are known faults that we have, but there's still 1,000 kilometers of offset. We can't find the faults. Okay, that's kind of the model I've been working with up to this point. But today's show is in a way a follow-up to what Brian Mahoney was saying to me in a rather strong way before Christmas. Mahoney basically said, you've been talking about the Intermontane and the insular. How come you're not talking about them together, moving south together and moving back north together? I think I said in that show, because I've never heard of that before, Brian. Well, I think, but I'm not sure. Randy is saying that he likes insular and Intermontane together, double parked next to the Sierra Nevada batholith in California 90 million years ago. And then we want this Megawhale, this massive amount of material, like double the width of a whale, not just the insular, moving north as a unit. Are you still saying that, Randy? Do you still like that concept? Do you really want the insular going south? Like, okay. That's what I want to do on the chalkboard, and I think I'm there. I'm coming to you right now, Randy. We'll see how much you want to. We'll start slow, but we'll ramp up into something that hopefully will feel good to you. Battery 100%. We go up to Sydney, British Columbia, and look for a friend. Different than Jane Wynn, can we find Randy Enkin?
Hey
Hello.
there.
How are you?
Really good.
Oh, good. How's the audio today?
5 by 5.
Okay, wonderful. I'm so thrilled to have you with us. I think your video will settle down. You look a little pixelated at the moment, but we'll assume that will just settle down for a second. So you're sitting in an office in Sydney, British Columbia. Am I right that you took over for Ted Irving?
Yeah. Ted was very conscientious. He said for years before he was 65, I'm leaving at 65, and you need a Paleo Mag Lab. And he lobbied hard. And I got the job.
How did he find you, and where did you hone your skills in the Paleomag world? I assume it wasn't like Jane, where you just showed up and learned it on the spot.
No. Let's start grade 11 geography. Great teacher in physical geography. That was, late 70s, and I learned about plate tectonics, and, that was wow. But I went into physics in Toronto, and then I did a master's in Toronto with David Dunlop on how rocks get magnetized.
Huh.
And then I had the big opportunity to go to Paris and work on a project in China. Did my doctorate with Vincent Courtillot at the Institut de Physique du Globe de Paris.
Wow.
And then a postdoc in Edinburgh, back in rock magnetism with Wynne Williams.
Okay.
And then the job advert came up, and it was my own field, my own country. So I got to come back to Canada, and that was 30 years ago, which just blows me away.
Yeah,
so I kind of inherited the Baja BC controversy. That was my first major project, was working on this. And I did until that review paper in 2006. And then maybe in question period, we'll talk about why I'm not doing that now. Yeah. But I have to say, it's such a gift, you bringing me back, looking at the topic. I have to say I still feel proud about the contribution I made. Yes. I think it's still relevant. It's not obsolete. And I think it's actually a really important topic, and you have a lot of courage bringing it up and going so in depth with it. So thank you.
Well, thank you, Randy. And I don't know, let's do it now before we get into the slides. Can you comment what factors contributed to you stepping away from all this?
For one, I think I had done what I could do.
Yeah.
And the controversy wasn't disappearing. I am conflict averse. And there's so much to do. I'm paid by the Canadian taxpayer. I really want to help societal problems. I'm looking at the ages of earthquakes. I'm looking at mineral exploration. I am a physicist working in a geological community, so it gives me a little bit of a superpower. And I just love working with geologists, even though that's not my background. Paleomagnetism is interesting. Half of the community are geology background, half are physics background.
Sure.
And so I'm definitely on the physics side.
Well,
but I get to work with geologists, and they're the best.
Well, that's nice to hear. I mean, come on now. You're the perfect person then to help us not only tackle some of these things that I threw on the chalkboard here, but also fill in some of the gaps that we may be missing. And I'm not sure what level you're wanting to go with your slides, but you asked for 10 minutes or maybe more about just kind of helping us see, maybe even revisiting some of the stuff we were trying to do with Bernie, let's say. So can we just bring your slides in, and I'd be happy to just kind of follow wherever you want to go.
Give me 15, and then I'm all yours.
Okay, let's do it. So here we go.
Okay, and we're going to start with an anecdote, actually the most important anecdote, and that's Continental Drift. So here's Ted Irving in the 1970s, but in 1951, he helped Keith Runcorn. Let's get this to working. There we go. We helped Keith Runcorn set up the Paleomag in Cambridge in Britain to study how the geomagnetic field works. They had no program to address continental drift. It is something that came out through their measurements. And what you see here, this was a 1956 review. This was the paper. If you ever want to study Paleomagnetism and continental drift, 1956. And so here in the small dots are where the North Pole was over time with respect to Europe. In the dark points is where North America was with respect, where the North Pole was with respect to North America. And you see we've got this rotation around the North Pole, which corresponds perfectly to the opening of the Atlantic Ocean. If you close the Atlantic Ocean, these two paths go on top of each other. But also, he had a few rocks from the Deccan Traps, 70 million years old in India. And look at that. The North Pole with respect to India was way far-sighted. Now, it doesn't mean that the North Pole was there. The North Pole was at the North Pole. What changed is India was way south of the equator, and it drifted up and collided against Asia, creating the Himalayas. Amazing story. Anyway, shortly before Ted died, he wrote up this wonderful memoir. Never finished it, so that's why it's not public. But he wrote, "Paleomagnetic controversies arise from a certain uniqueness, even strangeness, in the paleomagnetic method, enabling paleomagnetists to observe effects that cannot be observed by other means." And that continues to today. So the important thing in Ted's time is in the 50s, they thought that the continental drift meant that the continents were plowing through the oceanic crust. And the revolution, the plate tectonic revolution, in the sense of Kuhn's scientific revolutions, is they discovered that there are these structures in the ocean floor, and the continents are rafts floating on the continental floor, which is the thing that's moving. And it unified the earth sciences. Amazing thing, not anticipated when the Paleomag was saying that the continents drifted. Okay, so how does it work? And it is based on that fundamental work that was happening in Cambridge in the early 50s, which showed that the Earth's magnetic field, the geomagnetic field, has the geometry of a geocentric axial dipole. So what that does mean? A dipole means it has the geometry of a bar magnet, with the north and south pole. Geocentric means it's in the middle of the Earth. And axial, this one's key, is time average. When you average over time, say about 10,000 years, then it is aligned with the Earth's rotation. And what that means is we can work out Paleo Latitude. What is latitude? It's how far you are from the equator, or how close you are to the North Pole. If you know how close you are to the North Pole, you know your latitude at the time the rock was magnetized. So here's an example that we'll talk about later. But if you take any Cretaceous or 70 million year old rock from North America, you find that the North Pole, with respect to Cratonic or stable North America, is up here, just a bit north of Alaska. Does not mean that that's where the North Pole was. The North Pole was at the North Pole. It means all of North America was a bit further north and a bit counterclockwise rotated. Okay? Now, then you go to Yukon and you pick up these flood basalts you were just talking about, the Carmacks, and look at that. The North Pole isn't where the North Pole was in 70 million, like you would have seen if you were further east. No, you see it's far-sighted. So what you do is you take this arc, okay, from Carmacks up to its North Pole, hang it on where the North Pole used to have been, and it says that Carmacks was somewhere along this arc. You don't know the longitude. There's no longitude information. The Earth's magnetic field is symmetric, but you know the latitude, and it means that Carmacks was down somewhere around Vancouver Island.
Love it. Keep it going.
Okay. How do you do that? How do you get those directions? Well, you need to take oriented samples. And the best way to do that is with a rock drill. So we have a chainsaw motor and a steel tube and a crown impregnated with diamonds, and you put water through and you get totally covered with mud, and you create a little core like this, 1-inch diameter, 2.5 centimeter. And then you put a tube into that hole with a compass on the top, and you measure the plunge and the azimuth, the direction that you drilled. And you mark the top of the core, and you cut it up into little pieces, and you put it in a magnetometer. Magnetometer measures the magnetism. And the magnetism is a 3-dimensional vector. You're going to do a whole bunch of experiments with it to make sure that you've got a reliable, stable magnetism in these things. But basically, we're looking for the direction of magnetism in these little samples. Okay, how do we assess a paleomagnetic study? Well, It's a statistical quantity. The Earth's magnetic field is always shifting around. There's this thing called secular variation. But what you need is to have a lot of sites, and they have to span time. They have to be at least representing 10,000 years. Here are a couple of specs. It's going to change depending on your application. But 15 sites, 6 specimens per site, and uncertainty, alpha 95, so 95% confidence interval, less than 15 degrees. That's pretty standard. Demagnetization. Rocks are complicated. Okay, so it's not like a nice lip bar magnet, which was engineered to be stable. You've got unstable parts and stable parts. You've got to demagnetize. You got to scrape off the soft stuff so you see the hard magnetism. I'm not going to go into how to read these orthogonal plots, but what you're looking for, lots of points and in a straight line to the origin. That's the yummy stuff. You see that? It feels good. Okay, paleohorizontal. We've talked about this a lot in this series, but we're in a crunch zone, the orogeny. The Cordillera was made by crunching rocks, and anything more than 10 million years old that I've seen is tilted. So if you can't see that tilt, you're in trouble. But a lot of rocks, sediments, many volcanics were laid down by the gravitational field, and you can measure that tilt, and you can place it down in its original orientation. You can rotate around the strike, and you rotate the fossil magnetism like it's an arrow frozen in the rock. You rotate that along with the beds to get it to its paleohorizontal, ancient horizontal. Okay, field tests. You've done everything you can so far, but you also have to do these tests to see that you have stable magnetism. I'm not going to go into these, maybe in the questions that we'll have time, but we have these things, the tilt test, the contact test, the conglomerate test, and we always have our eyes out when we're in the field looking for these various geological field tests that we try to do. And the last one is a bit tricky. I'm putting it in the discussion, but what happens is some rocks, they have these elongated grains that hold the magnetism, and if the magnetism is acquired before a rock squishes, it can be shallowed. And you have to do tests to see that that hasn't happened. Okay, now we go to Baja BC. So in the up to the 80s, only plutons had been measured. And I have to say, if I were Ted Irving in 1985 and I saw it, we had all of these Cretaceous poles and Cretaceous sites, and they all went to these poles. They're all far-sighted and right-hand rotated. I'd say this is solved, no problem. And he's got this with Jane. They wrote this wonderful review. These rocks were magnetized down south, and then as they moved north, they were like ball bearings, and they all had that kind of dextral shear and rotation, clockwise rotation. Beautiful. But they're not bedded rocks, and so they started a program in the 90s looking for bedded rocks. That was recognized as the weakness. There are these 3 fantastic papers in the Journal of Geophysical Research. And the last one, this review in 1996, this is the punchline. As you go from west to east, from the insular superterrane to cratonic North America, you see less and less latitudinal displacement. And somewhere between the insular superterrane and the intermontane, somehow we're hiding 1,000 to 2,000 kilometers of motion. So let's first of all focus on these red ones. Silver Powell Creek, that's Mount Tatlow, and Spences Bridge, which is Spences Bridge. All right, so this is a picture of Daryl Collins, but it's basically your stomping ground. You live down here somewhere, and there's Mount Stewart, so you're down here even. But the Fraser Straight Creek Fault has been restored 110 kilometers. Okay, so everything on the left has been moved down, on the right has been moved up, and you can see that Mount Tatlow and Spences Bridge were really very close when, what was that, 50 million years ago was that motion on the Fraser Fault. But this is all we got between those two. So somewhere in here, according to the 1996 interpretation, there's hiding over 1,000 kilometers of motion.
Yeah.
Then Brian Mahoney, working with Kathy Hickson in the Geological Survey of Canada, is mapping that area, and he knows that the equivalent of Spences Bridge is right in stratigraphic contact with rocks that, these chert pebble conglomerates, Albion chert pebble conglomerates, that are equivalent to the Silver Quick. And then with Paul Link, they have a master's student, Jim Riesterer, who digs around and he can put his finger on the contact.
Mm-hmm.
That doesn't look like 1,000 kilometers of motion. Okay, let's take a look at the Paleomag. So first of all, we are in Churn Creek. There's Gang Ranch and Lone Cabin Creek. And we had this wonderful student, Michelle Haskin, who led this study. And punchline, look at that. Spences Bridge. This is the North Pole with respect to Spences Bridge. Here's the North Pole of Empire Valley compared to its location. They're the same. A little bit of rotation, that's okay. But they're the same latitude. And so that puts them down here. Is that Oregon? Is that Northern California? That's where they are. Now, Spences Bridge. Jane studied Mount Tatlow. Remember, she showed she had a north and a south transect, and she had one site up here at Ted Angela.
Yeah.
So we took a whole bunch more sites, but most important, we took sites in Churn Creek, and these guys are in stratigraphic contact with these guys. Okay? But 104 million years, Spences Bridge andesites, and here we have the Silver Quick Powell Creek, somewhere around 90, 95 million in the Albion. Okay, and there's some vertical axis rotation. I don't care about vertical axis rotation. What's really cool is that the Cordillera in the Cretaceous, so 100 million years ago, was aligned with the North Pole. So variations in latitude are easily seen with paleomagnetism. It's very fortuitous. And what we see is there's some rotation, but they're all far-sighted. And they're all far-sighted by about the same amount, which would put this part of the world down south of California. And I think any paleomagnetist would say that this is one of the best defined, most reliable results in the whole international world and 70 years of paleomagnetism. 5 localities, each with its own positive tilt tests, contact tests, conglomerate tests. We have volcanic flows and sedimentary strata. It passes the inclination shallowing test, and it's 20 degrees far-sighted. So, back to that diagram you had on the board. Over here is Jane's Mount Tatlow result. Albion pebble, chert pebble conglomerate, and it is lithologically, geochronologically, and paleomagnetically identical to the conglomerate of Churn Creek. That's called a correlation. Over here, we have these Albion 104 million year andesites, same lithology, same age, and same paleomagnetic record. I have to hand it to Brian Mahoney. He did not say, I don't believe the Paleomag. He said, if the Paleomag is correct, then we should see exactly this. These guys are going to be the same. These are going to be the same. And he worked hard with us. My goodness, that guy works hard. Anyway, he took us out there, showed us around, and it worked. Got to add in Judith Baker. Judith Baker was my lab and field assistant, awesome person to work with for many, many years. Okay, so there's the Megawhale.
Well, you came up with it. That's perfect. Look at that. Thank you, Randy.
We came across that same word just yesterday. I made this last night just for you.
Thank you.
So it's not just that we've got a little or a big whale. The insular superterrane is big, but it's the Intermontane and the insular together. Okay, let's go up north. So what's happening here? I thought you'd like that.
Oh, my God. Yeah. Can't believe it.
Markey and Globerman in the 80s took a look at these beautiful flood basalts in Yukon. And then my very first field work with Jane Wynn in 1993. This was where we got to go up on the mountains and teach each other how we did Paleomag, and we, figured it out together. Anyway, we did a lovely paper, Jane as first author on the Carmacks. And then after that famous 1999 Penrose Conference in Winthrop, Washington, then went up with Steve Johnson, and we went even further east. We were thinking maybe the Teslin Fault is it. Who knows? Not very big, but so we took a little island or cap of Carmacks, which was identified over here in Solitary Mountain, and back to that picture that we saw at the beginning. This is what Jane and I got for Carmacks west of the Teslin Fault. Again, far-sighted. Yeah. The North American pole is no longer down here because we're not talking about 95 million years ago. We're talking about 70 million years ago. And there's Solitary Mountain. I don't care about rotations. There's all sorts of strike-slip faults, rotations a dime a dozen. What's important is this arc length. The distance to the North Pole is the same. And if you hang that distance from where we know the North Pole was, then it's down here. But it's a problem because very fastidious, careful geology is saying that the Carmacks is on the Yukon-Tanana terrain. The Yukon-Tanana terrain is on the continental platform. The continental platform is part of Cratonic North America. Okay, reconciliations. Well, first of all, let's talk about the poles. So the reference poles. And so my review was done back in the early 2000s. As far as I could see, Bernie's initial data is the same as what I was doing, but a complementary method. He only looked at North America. These are the dark green poles. And he was really careful with the dating. All very good things. I'm looking only at one dimension. I'm looking at what would be the Paleolatitude at the site of Mount Tatlow, right in the middle of all the action. Okay, so this is just not worrying about rotation, just looking at Paleolatitude. And you can see these poles that I've transferred from all over the world are producing this really nice line, and it's pretty stable during most of the Cretaceous. It's only once we get to the Paleocene, the Tertiary, that North America starts moving south again. Okay.
Yep.
I think it looks pretty good, pretty robust. Different people have been looking at it for a long time. Maybe that 500 you talked about in the introduction, that 500 kilometers, might be because of the difference between how Bernie and I looking at the reference pole. But that would be max. Okay. Yep. Maybe the problem is with the Baja BC magnetism. There's a lot of poles. My preference is to hang your hat on the really solid ones, but let's take a look. These are the Paleolatitudes of all of those data. And, they're a bit all over the place, but there is this tendency to be south. But I'm going to suggest that it is more important to hang your hat on the ones that fit all the criteria.
Okay.
And then what we see is North America. So this point, if it were firmly attached to North America, would follow the green line. And the fuzziness there is the 95% confidence interval.
Yep.
Based on the measurements. Mm-hmm. And then here is each one of these lozenges is the 95% interval of Paleolatitude for each of these studies. So Nanaimo group, Carmacks. And when we do this, we get about maximum 2,100 kilometers, plus or minus 700. It doesn't stop this Megawhale from being offshore, that beautiful triad of subduction in California. I was thinking when I did this, maybe I'll be able to pull it down under 1,500, maybe 1,000 kilometers, but no. And I, look, my life would be easier if I could reconcile Baja BC. I wanted to, I couldn't.
Yeah. All
right, so maybe the problem is with the paleomagnetic method. And I remember Brian in his interview with you said, that's got to be it, because everything else is ironclad. Yeah. So it has to be something fundamental. And what I say there is, why would these really solid methods be pathological here and not other times? We're playing with fire. Like, maybe Brian is right. That's great. But it is a hell of a statement. Yeah. I don't want to go there. And he's sad I don't want to go there because it would make his life better also. Anyway, so then geology. Now, I'm not a geologist, but I work with some of the best geologists in the world. And I have to say that they are working with integrity. I don't know anybody in the Baja BC controversy who I think is a flake, who is just trying to do something quick and dirty. Okay? I'm so impressed. I'm going to bring the picture back, because I want to bring back, this is Steve Johnson's terrain wreck. And if something was going to break the logjam, what I really like about this, that we have that vergence, that triad in California. We've got the same sort of vergence, of subduction vergence, coming into North America, but you see how it kind of wraps around in the in what he calls the Great Alaskan Terrain Wreck. It's like a train wreck. These cars are flipping around, and that is, at face value, the signature of northward motion of a ribbon continent. And then he goes on and talks about how there was westward subduction leading to the Cretaceous plutons that are too far away from the subduction zone off in the west. Anyway, you get to ask him about that. It's impressive to me, but there are problems, because there's lots of people who say you can walk from Calgary right across to Vancouver without crossing any major faults. Okay, so here are my conclusions. Pretty well my 2006 vintage conclusions, and I'm really ready to have somebody wow me with the difference. But we are on the horns of a dilemma. But it's not because anybody is misrepresenting or cheating or doing anything wrong. We're applying time-tested techniques, and it's a wonderful laboratory to figure it out. But the burden of proof for all disciplines is high here. Lots of time you see a map and you don't actually know why it is that the geologist is coloring this and this and this purple. But, in this case, nobody's getting away with being sloppy. We're getting a lot of dates. We're getting a lot of detrital zircons. We're getting all the paleontology. It's detailed work. And this is not the 50s that Ted was doing his Continental Drift in, right? Like we're talking about a very mature plate tectonic community that we're doing this. Okay, I also want to say in my conclusions that the paleomagnetism is, well, some of it is as good as any. I have to say, some of the papers that I have published, I had to be really jabbed in the side to say, yeah, we got to publish. You've done a lot of work. I'm not really happy with Nanaimo Group, I hate to say. Those rocks are not stably magnetized. It's got some good things in it, but it's not one that I'm going to hang my hat on. Okay? And then people have been talking about the Metau volcanics. We only took 4 sites, 4.
Oh.
And they're remagnetized. Okay? You wanted to talk about remagnetization. That might come up in the conversation. They are not an original magnetization. They happened while the rocks were tilting. And so we don't really know what the paleohorizontal is. Anyway, my last point, promise, is that the paleomagnetism, along with the geological correlations that go into it, says that Baja BC is very large. But that makes the problem worse because it means that the trace of that motion has been remarkably hidden. And, you know, when I have these conversations with these people that I respect so much, like Brian, we keep talking about special pleading. You know, what you're asking for is special pleading. And so that's why I could not write a paper with him saying that paleomagnetism in Mount Tatlow didn't work because maybe this, maybe that. There's a bunch of special pleading I couldn't do. But in the same breath, I can't really ask Brian to say that his detroidal zircons in the Nanaimo group are not telling him that there's Belt Purcell supergroup in there. There are. Yeah. I don't have the solution. Now I measure the ages of earthquakes.
Okay, well, my God, how many questions I have? A million. And we have, the viewers have, hydrate yourself, for Christ's sake, Randy. Come on now. That was, I was keeping my eye on the live chat, glancing over occasionally. People are loving this. So great job. I'm just so pleased with that. And it did give us a nice foundation. We've been flirting with some of those ideas, but it was just great to see it in a coherent manner like that. Let's start. Oh God, where do I start? Let's start with my last question to Jane was, or one of the viewers asked, does everybody in Paleomag kind of see it the same way? Do you feel like most Paleomag people are lots of displacement people and you're one of the few Paleomag people that is a little bit different than that? Okay,
anecdote at the AGU once. I was talking to Neil Updike, one of the greats. He's recently dead. And I remember him saying very clearly when I was talking about my misgivings, said, if Ted Irving believes it, it's true.
Oh,
Ted had an amazing intuition. And based on insufficient data, he was really often correct. But, you know, I know that you're friends with Bob Butler.
Yeah.
Bob never really bought the big displacements, mostly because of issues with plutons. He didn't work with any bedded rocks, but he would be more on the 3 on your scale. I'm not a 9. I've told you, I corresponded with you. I'm a 7, which doesn't mean 7 in terms of how far, but, you know, I go back and forth. I think the Paleomag is good, but there's a problem. I would think that paleomagnetists who there's been so many times the paleomagnetism has eventually won out that I would think that as a community, we're going to say geologists are put on Earth to find correlations, even when they're not there.
Yeah, yeah.
And I don't mean that in an insulting way. It's just,
right.
It is part of the training.
Huh. Well, I without even reading the comments yet, I can probably guess that some people are like, so what is the answer for Churn Creek? Why would you have these two completely different paleomagnetic signatures conformably on top of each other? And you're saying, I don't know either. Beats me. Like,
okay, there's two reconciliations.
Okay.
One is that Spences Bridge and the Churn Creek volcanics are really saying that the displacement was only 800 kilometers, and then 10 million years later, maybe 5, we're down at, say, 2,000.
Okay, yeah.
At best, we're talking 10 centimeters a year. At worst, we're talking 40 centimeters a year. 40 centimeters, well, there's this thing people talk about, the maximum speed limit of plate tectonic motions.
Yeah.
On Earth right now, the East Pacific rise is going at, I think, 12 centimeters a year. And there's some thought that like 15 is about as fast as it can go.
Huh.
And then other people say, well, no, if you have like a watermelon pit getting squished through, then you can have these small, like a little ribbon continent, be squished up. That's one way that you might go above the speed limit. But the first big class of solutions is yo-yo tectonics. Not like you did in the introduction. Nobody has ever said that Spences Bridge was at 54 north.
Oh, okay.
Never. Impossible.
Okay. All right.
Not ever uttered. Okay.
I wonder where I got that. Go ahead.
Is it because the North Pole was further south? You see, there's no point going against the North Pole. You got to go against Cratonic North America.
Yeah, yeah.
The rotation point of the Earth is not important. It can move anywhere. There's something called true polar wander.
Yeah.
It doesn't come into this at all. What we want to know is, what is the plate-to-plate velocity? Because that's where you get the earthquakes, the mountains, the rifts, whatever. Okay, so did the Megawhale, did Intermontane, insular, superterranean go south and then north? Or if I had to throw one of the good poles under the bus, it would be Spences Bridge. Spences Bridge actually has a problem.
Oh.
It has a problem, always has. We are transparent about it. It's just people don't read every single line. It is it has what's called an early syntectonic signature, which might be a remagnetization. We explained it in terms of uncertainty in the bedding measurements because it's kind of hard to measure bedding in a volcanic pile. It's not like sediments. That was our interpretation of the day, but it would be nice. It would feel a bit better if we didn't have to go south quite so quickly.
Yeah, yeah.
So part of me feels that might be a weakness, whereas the Silver Creek, the Mount Tatlow and its equivalents, as good as it gets.
From south to north, but I guess I'm still confused on why we need insular to go south with Intermontane. Have you already just said it and I missed it?
They're stuck together at the hip since at least Spences Bridge time, and very likely since the Jurassic. There's lots and lots of work about how they form together, actually, in the lower Jurassic. Carol Evanchik did work on that. Margot McMecken, I think. There's a lot of links between the insular and the intermontane superterrain in the Jurassic, up in the Bowser Basin, places like that. So if we talk about intermontane, we're also talking insular. In the Baja BC, that makes sense to me. And incidentally, I don't think you'll see Sabia, the Siberia, Alaska, Yukon, British Columbia of Steve Johnson, or Rubia with Bob Hildebrand. I don't think they're trying to separate that. I think the only person of the new generation of pulling things apart and reconciling Baja BC is going to be Basil Teacoff.
Okay. Well,
and, I was a reviewer of that paper, and what I said is, there is this little fact that I don't agree with, but you still have to publish this. This is an amazing paper.
Well, that right there was really helpful, and I'm going to continue to think along those lines. Obviously, we're going to visit with Steve Johnston. We're going to visit with Bob Hildebrand twice. And I mean, I barely know the Johnston stuff yet, but how far east are these guys going? In your paper, you said you got to go east of the Tintina with your Megawhale.
Oh, yeah. Tintina is beautifully constrained at 400 kilometers. Beautifully constrained. But tertiary, like in the last 50 million years, what happened between, remember, we're talking between 85 and 55 million. That is the period of this northward motion.
Right.
And the Tintina fault is not, nobody thought of the Tintina fault 60, 70 million years ago. That formed later. Okay, so it's somewhere in this package that looks continuous, but in the Steve Johnson world is hiding the structure. I guess what I would like, if the geology gods are listening to me, what I would like is there to be westward subduction under the Intermontane, hiding in the shale, you know where the Burgess Shale is, that's right on this thing called the Cathedral Escarpment. And then it goes from limestone or carbonate to shale. And then we start seeing these plutons, which look like they are marking westward vergence, not eastward vergence. And that is a signature of a closing basin. But where are the ophiolites? Where's the strike slip faults? I want to see those. Okay, my doctorate was in China, right? It was called The Formation and Deformation of Asia. That was my thesis title. And one of the big things is India. Remember, India crashed into Asia, created the Himalayas. And while it did it, it squished out Indochina. And there's a fault there called the Red River Fault. 1,200 kilometers, and you can see it from space. And it's got gneisses in it that are only 30 million years old. How do you get a gneiss up to the surface that's that young? It's because there's a little bit of vertical in this strike slip motion. So that's work done down the hall from where I did my work in Paris was Paul Taponier's lab. And they did some amazing stuff.
I am loving this, and you're also setting up the next few shows on a silver platter for us, so thank you for that. Viewers, we're coming to you in a second. I have no idea how you want to jump on this because this is, my God, this is amazing stuff. I think I have one question to get us to the viewers, and that is, since you have all this experience with Paleomag in other parts of the world, Randy, is this just an American thing where a bunch of geologists are like resisting the Paleomag?
No. I think in the Geological Survey of Canada, there's probably about 30 people actively involved in this, and I think I might be the only one who actually believes in Baja BC.
Okay.
This is my community. These are the people I work with, and they're good, and I trust them.
Yeah. Amazing stuff. Uppercase viewers, you got a few more minutes, Randy? I hope you do. I mean, we want to tailor this. And
this is a real treat for me.
Likewise, for all of us. And viewers, you don't have to be on the level that Randy's been for the last 15 minutes necessarily. You can come whatever level you want. This guy's going to be able to help you, help all of us with any kind of question that you have. Okay. MMMH205 asks, can the lower lip of the whale have snagged on the jagged coast and got caught and pushed south? How about that one?
Okay, let's try to parse what they're asking. By the whale, they're talking about Baja BC.
Yes.
And it's not really talking about friction and things, but yes, when plates are interacting along boundaries between each other, that's where you get all these interesting things. And you had a lovely thing where you took a whale piece of bread and broke it up. And that's certainly happening. That's why we get these vertical axis rotations and things. But as to the specific of that question, I don't know. Remember that the forces that the crust is subjected to are much, much bigger than the strength of the crust. The crust is passively moving along on these big currents and mantle forces. And I guess a thing that I like to remember is it's difficult lifting a bucket of paint. Imagine what it's like lifting a mountain to create a mountain. It's the same forces. It's the same energy. And so, it's hard. And so, yeah, are things going to break apart as they are being pushed past each other? Oh, yeah.
Paul says, I give this a 10 by 10. Refreshing talk. There's tons of comments like that, Randy. So let's just keep going. Will asks, what's happening with the Rocky Mountain Trench near the Alberta border? How old is it?
Well, so you have the Tintina Trench, which smoothly turns into the Northern Rocky Mountain Trench, and that all is a strike slip fault. But by the time you get down to, down the Trans-Canada Highway, it appears just to be a normal fault. And there are correlations straight across it. Age. Basically, if I understand correctly, we got the mountains built up, and when the convergence stopped and when there was more strike slip along the west coast of Vancouver Island, then it collapsed. And so you get extension, north-south extension. You get all these core complexes, and you've got the rift there as a collapse feature. And that is, post Rockies, so 50 million years ago.
Let's keep it going. Dave wonders, Carmacks and Yellowstone hotspot. You kind of backed off of that, it seems.
Oh, no. I love that one. Okay. So, hotspots. Hotspots, there are different flavors. Some are started down 3,000 kilometers at the core mantle boundary, and they come up, and they're pretty stable in position. Hawaii's one of those. Other ones are from discontinuities a bit higher, and probably Yellowstone started as one of those little guys, and it's been coming up. And so in the last 12 million years or so, it's the Snake River Valley, ending with the volcanism that you see today in Yellowstone. But you go back in time, and then somewhere around where you live is where the beginning was. Was it the beginning of the Columbia River basalts? What Steve and Don Francis were saying is that it actually goes back to 70 million years ago. So that was the beginning of the hotspot, and then that little bit of it went up north, and the hotspot stayed in its same place down in the States. Other things that are cool about it: all the rocks underneath the Carmacks are remagnetized in the direction of the Carmacks. It's just remarkable. This is what Jane called the big flush. So our paper together was called the big flush, because you had the Carmacks, and then you had the Jurassic and Triassic rocks below it, all magnetized in the direction of the Carmacks. So it was a big heat source. The Carmacks covered all of the Yukon Trough, and then we just have an erosional fragment left. And then Don Francis saw that the chemistry of it is really exotic. What is it? It's full of potassium, I think, which means that it's a very hot and very deep sourced magma chamber. Outside my field, but that's what I recall.
That's great. So Carmacks, the metal overprinted or remagnetized. How do you know that happened, and why does it happen?
How do you know? First of all, it fails the field tests. Okay, so we've got my favorite one is, so let's say the rocks were magnetized. You see, get that right. Their magnetism is parallel in different limbs of a anticline.
Yep.
And then it gets bent, and I measure the magnetism. They're different the way they are right now, but when I untilt them, they're the same. That means the magnetism predates the tilting.
Yep.
But how about, let's get this right. There we go.
Yeah.
So we measure it, and today, it's very hard with the screen. Okay, that's how we measure it today.
Yeah.
And then when we untilt it,
right,
then the magnetism no longer is in the same direction. They diverge. They're the same, they diverge. Okay, that means that the magnetism postdates the tilting. So if you take a look at the Nordenski Old Formation or the Mandana Formation underneath the Carmacks, you get the negative tilt test. Okay, then let's do the contact test. In the contact test, this gets more to how things get remagnetized.
Yeah.
The magnetism is held in iron oxides. They rust. They're very susceptible to chemical change. So if you put hot fluids through these rocks, then they very, very easily remagnetized. Okay, they recrystallize in the field at the time that the fluids were going through. So that's what we're saying is happening in the big flush. Okay, and so what we got, I remember very nicely, just west of Whitehorse, we had a negative tilt test, but a positive contact test. There was an Eocene dike that went through these beautiful red sediments, and the dike had a particular direction, and as you moved away from that dike, you could see in the country rock in the Mandana, so nice black dike, nice black crack in the rock, and then right next to it, you saw the same direction. And a bit further away, you start seeing a bit of that, a bit of the country rock. And then once you get far away, we didn't see a Triassic direction. We saw that Cretaceous direction from the rocks that were above it. So that means these rocks were laid down in the Triassic. Then came the Carmacks, remagnetized everything underneath it. Then came this 50-million-year-old dike and just remagnetized a tiny bit around it. So I know that it's older than that contact test, but predates the tilting.
You are good. Like, Have you taught before?
Oh yeah, a little.
Like, you've got a knack for just, I mean, most of us would have to practice that a million times to be able to explain something like that. So wow.
I've only done it about 1,000 times.
Okay. By the way, is this the first time in 15 years you've really been like talking about Baja BC type stuff? Have you like totally like left it, like left?
As research, I've left it. As research, the Canadian taxpayer is not paying for me to do Baja BC anymore.
Yeah.
No, it's never going to leave me. I love it. I find it's a really good way when I get a school tour pre-COVID. We used to have kids come here all the time into the Pacific Geoscience Center, and doing outreach is great. And yeah, I would tell the story because it's such a ripping great trail, and it's a good way to teach how the Cordillera works. Gets kids to open their eyes to where they live.
Yeah. Wow. Yeah, a few more. I'm going to scroll back now, looking for some other questions. I don't know if anything bubbles up in your mind, Randy, that you feel like you want to comment on. Just, I mean, you've already done. It's all gravy from here now. Come on. Yes. So Backcountry Gary Paul asks, I think what I was going to ask. In addition to Spences Bridge, possibly revisiting that and whatever, taking more samples or something, where else would you go to get additional PMAG data to try to sort this out?
Okay. No, I mean, we tried a lot.
Yeah.
A huge disappointment is the older rocks. There are very few stable magnetisms that are older than mid-Cretaceous. The orogeny was the time that there is fluids and heat going through these rocks, and unfortunately, we're not seeing very much before. When I came back to Canada in 1993, I really was keen to look at the Jurassic. The Jurassic is a wild time, paleomagnetically all over the world. But I tried many times and I failed. There's this wonderful story of Stachenia and Quinellia kind of wrapping around the Cache Creek terrain, or are they strike slipped? And so I've done some work with colleagues trying to see whether there's this huge orocline around the Yukon Tanana. Yeah. Fail. But doesn't mean that there's somewhere, the mountains are big, mapping continues, and there's going to be somewhere some rocks that will help that along. Cretaceous rocks.
Yeah, well, let me just add a little bit more to that. I feel, again, I haven't read much yet about the Alaskan terrain wreck, and I still haven't read all the details of Hildebrand. I got some work to do before he shows up, but I get the sense...
And his books are only that thick.
Right. I get the sense we're going farther and farther east for major faults, but also are we going earlier and earlier in the story? Like, I've been so obsessed with 100 million years ago and the Cretaceous stuff, but I don't think about the Jurassic at all.
I'm so dissatisfied that we don't know what's happening before. Now, on the other side, I have done a lot of sampling in the Rockies. Now, those are usually Paleozoic. There's not very much young in there. Yeah. There is the Crow's Nest volcanics. That's non-negligible. Oh, right. But going back to the original data, because I have access to all of Ted and Jane's original data, it really, it's only an outcrop which is about 200 meters thick on the road, and most of it is remagnetized. They talk about that in the paper, but the stuff that is stably magnetized is actually from one knob, so it's really only about 10 meters. And so I actually support their idea that is a secular variation. It's not sampling 10,000 years. On the other hand, what we're seeing all the way down for 500 kilometers along strike in the Rockies, are these Cretaceous overprints, which are totally steep, meaning North American in direction. And I do talk about that in this review paper. And so that puts the eastern boundary in the Rockies. Like, the Rockies are part of North America, which is a damn good thing because you can actually watch the stratigraphy from the Canadian basin, Western Canadian Sedimentary Basin, all the way out to, you know, the main ranges to the BC border. You can trace those individual beds. I would feel really weird if the Paleomag gave anything other than that.
Is that a future area? Like, how much Paleomag has been done in the Belt supergroup?
Belt is okay. The belt is a big problem. If the belt is, well, first of all, I really have a hard time saying the belt is actually North America and Baja BC because there are some amazing little ultra fine correlating marker beds in the belt supergroup. So I'm really hoping that's not the solution. But the mid-Proterozoic, so 1,450 million years ago, and it's got a pretty North American-looking direction in it. It didn't get remagnetized, which is interesting. They're hematite-bearing rocks, which didn't get remagnetized like the magnetite-bearing carbonates.
Huh.
But the belt, you know what? Belt is ripe for some more work.
Huh, interesting. Wow. Okay, 3 more and I think we're done. I always feel like I'm ripping off the viewers here. I'm hogging all the time, but I'm just working my way back. Leslie says, can't Basil's shear zones answer this problem? So Western Idaho's shear zone, I don't know if you have any comment there.
He makes such a beautiful story. And the thing is, both Bob Hildebrand and Basil Tekoff are extending the story into the United States in a way that I have been gloriously ignorant. And but certainly for the Intermontane part of Basil's story, absolutely the shear zone, the Idaho shear zone, that's the sort of thing you're looking for.
Yeah.
Where I said when I reviewed their paper is I think you can't disregard the linkages between Intermontane and insular super terrains. Prove me wrong, Basil.
Yeah.
I'd love it. I'm not scared of data. I just...
Okay, Geneva asks, is it eligible to not compare the Paleomag data of the Intermontane and the insular to Cratonic North America? He goes on, North America moved around so much that it's hard to tell where it's been long before. Just to focus on the younger stuff, like the Intermontane, for instance.
Okay, so are we looking at the position of these poles with respect to the North Pole or against what they're crunching against? And I say it's against what they're crunching against. And the wonderful thing with North America is it's part of this great plate tectonic circuit. You can use the magnetic stripes on the Atlantic Ocean floor to see where Europe and where Africa were with respect to North America. And then with that, you can see where South America and Antarctica were. And so we're not just looking at North America, we're actually looking at the whole world and getting Paleomag poles from all over. And they tell a coherent story.
Wow. Last one, since you mentioned ocean crust, Russell Sr. wonders, could the strike slip have occurred on an ocean crust boundary?
Yes, but where is it? Usually, when you close an ocean basin, little bits of it get stuck. And you get blue schists, you get ophiolites, you get there's some trace of it. We want to trace.
And
Hey, I want to show you
looking at-
something.
Yeah,
part of
please,
the reason,
please.
part of the reason that I wanted to do the interview for my office was so you can see
Uh-oh.
these are the bound volumes of Paleomag papers that I inherited from Ted.
Oh, wow. That is so cool.
What a resource I get. Also, he retired in 1993. He died in 2014, but he was active. He was very nice. He took an office in the far corner of the room. He didn't want to, breathe down my neck. Yeah. But boy, what a resource, what a mentor he was.
Well, that just brings it all together just perfectly to learn from Jane and to learn from you as well, and to get a very clear picture of what that scene is there. I'm so grateful to you both, and especially you today, Randy, for revisiting much of this stuff, especially since you haven't been deep into the research recently. You still have just so much to offer us, and I'm so grateful to you. So thank you. Anything else you wanted to add before we say goodbye?
It's a pleasure. When you first asked me, and I was thinking, why do you want to talk to me?
Yeah.
Go talk to Teacoff. Go talk to Hausen. Right. I'm really pleased. It's been wonderful going back, reading the new papers, and seeing that what I did was not obsolete.
Oh gosh, no. And so many folks are going to have been already, but will continue to read those papers. And it's a major contribution. And obviously we will continue to just try to wrap our minds around your work and just fold it in with some of the other stuff we're learning as we continue the alphabet. So,
well, I'm looking forward to the rest.
Okay. Well, thank you. Well, thank you, Randy. Great job today. Loved what you did, and I'm sure everybody else agrees with that. So have a good afternoon, and we'll see you next time. Goodbye.
Bye.
Wow. I think I cut him off too quick. He was in the middle of goodbye. So I'm sorry, Randy, if I cut you off verbally there before we said goodbye properly. Oh, man. I've got all sorts of new ideas. I've got some satisfaction with some of the basics that we were trying to do in previous shows. I don't know how you're feeling, but I got so much out of that. So thanks again to Randy. I think before we close, I do want to go to the laptop and show you the 3 Randy papers, a couple other things that I've tossed in to the website, and then we will enjoy some rum cake together before we say goodbye. So he goes to the laptop for the first time today. That's a new twist. And nickzentner.com is the place to go. You know that by now, and we're clicking on Baja in the upper right-hand corner where we have all these papers. Seems like many of you are visiting these papers, which I'm very grateful for your time and your energy. Let's enlarge this a bit. So after hang on. Sorry, Patrick. For the come on, man. There. So in the last show, we were visiting with Jane, and Jane mentioned that, hey, there's this kind of overlooked paper, that's the way I heard her say it, of the crow's nest that she and Ted did pretty early. That may be one of the first papers that Jane co-authored with Ted. And Jane was wondering, do you remember this? She was wondering if this might be a paper that is worth a second look from some of us who are continuing to think further east. Remember, that's our theme now. We're going east, and we're going potentially older than we have been earlier. So I've barely looked at this paper, thanks to the email from one of the viewers who saved me some time and emailed me this paper. Thank you. I didn't jot down your name, sorry. But, what do we have here with the crow's nest? And Randy brought it up a little bit too, if you recall. Also from Oh man, I forgot now. Somewhere along the line, maybe I was just kind of thinking out loud and going, well, wait a minute. There was somebody who did some work with the shapes of the fossil leaves in the Winthrop Formation, which is correlative with some of the Mount Tatlow material. So here's that paper from 2006. Ian Miller at Yale, and some of the familiar Daryl Collins type looking things. But he gets down to, I know nothing about this, but pretty pictures of statistics, pretty pictures of, come on, man, I'm getting seasick. Where are the leaves? There. So what do I know? But careful work with these fossil leaves collected from the Winthrop is additional evidence that we were at southern latitudes, apparently. And then here's our new friend, Randy Enkin, joint paper with Brian Mahoney, joint paper with Steve Johnston, and then a solo paper, kind of a look at the whole thing. And Randy skillfully wove in a number of these concepts into our discussion today. I do have some slides for you, I guess, before we quit. Some directly from Randy, and then also possibly a look ahead, although I really don't know what's happening on Saturday morning, really. I've got a lot of work to do between now and then. You've seen this a number of times now, but I don't know, Basil's heading there, he says, but what's he going to find? One of the surprises to me today was Randy saying that possibly more work can be done with Spences Bridge, although I maybe missed the ramifications of that. This is, again, these are some talks that Randy emailed me. Here are some sites from Mount Tatlow, paleomagnetic sites from Mount Tatlow. There's the lone spot that Jane mentioned. I've never been up here. Squamish, my son keeps talking about how great it is in Squamish. I guess I need to get up there. So plutons, volcanic sediments, there's the Spences Bridge. Okay. And then, from the Bernie and Basil paper, here's Churn Creek with tons of displacement, and then Churn Creek with not very much displacement, both from the same site. What do you do with that? And then our buddy, the Carmacks. I'm glad that Randy shared this. I feel a little bit better about tracing North America's latitude. I'm more and more confident that that's the story. And then the lozenges, I think he said, that was kind of clever, to show this yo-yo effect. I still have work to do visualizing that. I almost interrupted Randy in the middle of that slide talk. I think I was well behaved. I didn't interrupt, but didn't Basil say there's this huge switch at 100 million years ago? Like everything's going south offshore, older than 100, and everything's going north offshore, starting 100? If that's true, why are we sending stuff south during this time that our major oceanic scene offshore is going north? What am I missing there? Same idea. Most of these were covered by Randy beautifully. Also from Randy, here's joined at the hip. Megawhale. I couldn't believe that. I didn't run that by him. We both landed on that phrase independently. That meeting of the minds, that was really exciting. So here's our Megawhale. According to Randy and Mahoney, they're joined and south they go. Incredible. And you remember Mahoney saying, like, that's a lot of land moving incredibly fast south past the Holy Trinity and then coming back north. Like, is that even possible? And now I'm just looking at pretty pictures. I guess that's enough. If you're still with us, if you're still with us live and you started at the beginning of this one, or if you're watching this in replay and you're watching these from beginning to end, I'm just impressed with you. I'm impressed with your dedication to stick with this. These are often dense shows. I think the guests have been outstanding recently, personally, but I guess I'm taking a moment to say this because we got a little wild there. In real time, I didn't catch everything Randy was saying. I'll enjoy the replay. I'll get a bit more of it. But I've already said this once or twice. The next handful of shows are going to be wild. And everything we think we know, we maybe don't know, which in the short term feels rotten. Like, I thought I knew some stuff. Damn it. I thought I knew some stuff. And then somebody goes, no. You don't know anything. Here's the story. And then you're like, oh, okay. Then you talk to the next person. They go, well, no. Here's the story. So if we're ready for that, if our minds are open, if our hearts are open, if we're just ready to listen to all these ideas, just that frame of mind and that frame of heart, I think that's the way to go. And again, I'm guessing, haven't seen the comments, but I'm guessing some of you during this show is like, I don't see this, I don't get it. Why are we even, you probably didn't say this, why are we even doing this if there's so many questions? Maybe I'm off, maybe nobody's saying that. But if you have that thought, please remember that we're doing this to learn from a number of people with deep knowledge, and we knew it wasn't all going to click together. And I know I've already said that. A toast to you. Here's to you for joining us today. Thank you. Here's to your health, your physical and your mental health, as you go about your busy daily lives. I assume you're busy. I don't know. Here's to your family and your friends in your community. Here's to Randy Enkin for an excellent job today. Thrilling to learn from him directly. So if you didn't catch it at the beginning of the show, I got a gift out in the hallway an hour ago, 2 hours ago, from Andrew Sadowski, who just returned from a winter vacation with his new wife, and they were down in the Caribbean. And so we're going to open a Caribbean rum cake made in by the Tortuga Caribbean Rum Cake Jamaica Limited, Tortuga House, Kingston, Jamaica, man. There's the telephone number. 876-926-3503-7. All right. I don't even need a knife. Maybe I do. This is like the backyard days or the house days where I'm opening gifts every day. Oh, cakes. Of course, I have to open it now. Megawhale. What a thrill. Don't cut yourself, boy. Woo! Okay, I don't want to get my keyboard all screwed up. So I'll do this. How about? So here's to you for joining us. And here's to me for a rum-soaked cake from Jamaica. Oh. There's some kind of chocolate or raisins or something on the top. Hello. Thank you, Andrew. I'll be weaving on my bicycle on the way home past Vinman's Bakery. Maybe I'll stop in and order a bunch of stuff while I'm drunk. Thank you. One more cheers to you to wet my whistle. Oh my God, that's strong. The schedule. I'm not sure what I'm going to call Saturday's show. I'm toying with the idea of calling it Vanishing Oceans. I might get talked out of it, but Vanishing Oceans, or Ocean Slabs, or Closing the Mescalera Ocean, or whatever the hell we end up calling it. Sorry, Patrick. Karin Seglock and Mitch Mahalanek will be with us together this coming Saturday, January 21st at 9 a.m. Pacific time. Can't wait for that. And most of my reading, preparing for that show, will be tomorrow, because Friday we will be entertaining our guest, Darcy Snowden, and she will be giving a noon talk in this room. And you are invited to join us live for that Darcy Snowden NASA talk, astronomy, Friday at noon. Thank you. I love you. And goodbye from Ellensburg, Washington, USA. See you Saturday, or see you Friday, or see you down the road sometime.